Okay, it gives us the centre of a circle. Centre is minus 2, 6. It also gives us a point on the circle. So really, what we can do is we can say, right, because we know the centre of the circle, we know that the equation of the circle is going to look something like x plus 2 squared plus y minus 6 squared equals r squared, okay, because we know what the centre is. So what we're going to have to do is to find what the radius is. Well, the radius is the distance from the centre to any point on the circle. So really, r squared is going to be, using Pythagoras, it's going to be 10 minus 2 squared plus 11 minus 6 squared. So that's 12 squared, 144, plus 5 squared, which is 25, equals 169. So you know that r equals 13. Okay, now, and that tells us that the equation of the circle is going to be x plus 2 squared plus y minus 6 squared equals 13 squared, or in other words 169. Okay, now, alright, so what we're going to have to do, it says show the circle also goes through the point 10, 1. So what we need to do is to substitute x equals 10 into our equation. Right, so x equals 10, we substitute that in and we're going to get 10 plus 2 is 12 squared plus y minus 6 squared equals 169. Can you see we're going to get an equation for y, and there's going to be two solutions, one of which should hopefully be 11, the point they give us, and the other one should be y equals 1. So let's just see though, y minus 6 squared equals 169 minus 144, which is 25. So y minus 6 is plus or minus root 25, which is plus or minus 5. Okay, so y equals 6 plus 5 equals 11, or y equals 6 minus 5, which equals 1. And then we've done it, yeah. Therefore, 10, 1, also on circle. Okay, that's done. Now, let's carry on. Part B. Tells us the tangent to the circle at the point 10, 11 meets the y-axis at point P, and the tangent at the point 10, 1 meets the y-axis at point Q. Show that the distance PQ is 58. So if I do a little sketch, so right here we've got a circle, not very well drawn, and we've got the centre of our circle, remember, was the point minus 2, 6, and I'll put in some axes. Axes are going to go something like, whoops, something like that. Okay, and that's x, that's y, and it tells us we've got these 2 points, the point 10, 1, which we'll say somewhere there, say 10, 1, and we'll call it point B, the point 10, 1, and the other one is the point 10, 11. Now I haven't drawn the circle very well, so let me just try and rub this out a bit. Eraser, okay, so right, let's try and draw it a little bit better. So right, okay, and click line, we do a line through there, kind of like that. Okay, right, it's only a sketch, but we've got one point there, the point 10, 1, and the other point it goes through is the point 10, 11, which is going to be something like that there. I'll call it point A. 10, 11. It then tells us we've got a tangent that goes through the point A, and that meets up with the y-axis at P. So if I draw it, it's going to look something like that. Okay, and then this point here is the point P, and this here is the tangent. Right, and similarly we've got another tangent here, and that's going to go through, that's going to go like that, and what we've got here is the point Q. Okay, right, and we need to find the distance PQ. Right, now to do this, what we need to do, we need to effectively try and find the equations for these two tangents. So we've got a tangent 1 there, and we've got a tangent 2, or I'll call that tangent Q, and that's tangent P. Right, now to find the equations of these tangents, what we need to do, we need to remember that the radius that goes from the centre to these points is going to make a right angle with the tangent. So that goes there, and that's going to be a right angle, and that one is also a right angle. Okay, so that's a right angle, and also that's a right angle. So what we do then is we say the gradient from O to A is equal to the change in y divided by the change in x. So it's 11 minus 6 over 10 minus 2, which is 5 over 12. And that means that the gradient of the tangent at P is going to equal minus 12 over 5. And I can then write an equation for the tangent, because it goes through the points 10, 11, so it's going to be y minus 11 equals minus 12 fifths x minus 10. I can then multiply through by 5. 5y minus 55 is minus 12x plus 120, which means I get, so when x is 0, when x equals 0, 5y equals 120 plus 55 is 175. So y at P equals 175 over 5, which is 35. So the y coordinate of P is 35. So P is the point 0, 35. If we do the same thing for Q, so start off looking at the gradient as we go from O to the point B. So the gradient from O to B is going to be the change in y 1 minus 6 divided by the change in x, which is 10 minus 2, which is minus 5 over 12. Therefore, the gradient of the tangent, tangent Q, is going to equal 12 over 5. So I can then write down my equation. Y minus 1 equals 12 over 5 x minus 10. Multiply through by 5. 5y minus 5 equals 12x minus 120. But when x is 0, so when x equals 0, we're going to get 5y equals 5 minus 120, which is minus 115. So y at q is minus 115 divided by 5, which is minus 23. Okay, so if the y coordinate of q is minus 23, so that's 0 minus 23, that means the length PQ, I hope you can see that the length PQ has got to be equal to 35 plus 23, which equals 58, as required. So it's a little bit messy, sorry about that. Also, really my point B, I suppose I should rub that. The point B I should draw a little bit better. So the point B, yeah, is here. Okay.